Welcome to the lecture series on microcontroller 8051. Today we'll be discussing about the logical instructions. So logical instructions include the AND instruction, the OR instruction, the XOR instruction. These are basically some of the logical instruction. Then we have the clear, the complement, the rotate right, rotate left, rotate right with carry, rotate left with carry, and then we have a swap function which is available in the 8051. So we will be discussing each one of them one by one, and we will see how uh, they work. Okay, so let's start with the AND function. So the mnemonics is ANL, and it is basically logical AND. So all the types of addressing modes can be taken care of by the AND instruction. Similarly, all the type of addressing modes can also be taken care of by the OR as well as the XOR instruction. While the interesting thing to note here is that these instructions clear, CPL, RL, RLC, RR, RRC and swap, they operate only on the accumulator. This is the accumulator. Okay, so this is quite important. So let's proceed. So these are the instructions that we will be looking into. One important thing is that the logical instructions do not affect the program status word. So that is important. Let's move forward and let's take some examples. Say example number 1 to illustrate how AND works in 8051. ANDing is basically bitwise. Okay, so each of the bit are ANDed with the bits of the other register. Say for example, I am using this number which is basically 0F, and I'm trying to say save it into A. So I'm writing move A comma hash 0FH. So this will save this particular number in the accumulator. Then I am trying to AND this the content of A with this number. Okay, so what is this number? This is basically uh, AC. This is ACH. Okay, so I will be writing here ANL A comma hash A C. So 0 should proceed A. So 0 AC H. Okay, so after the execution of this instruction, so I will be getting this value. So basically AND operation, and we know the truth table of AND. So X, Y, and say this is AND. So 0, 0, I get the output 0. For 0, 1, I'm getting 0. For 1, 0, it is again 0, and only for 1, 1, it is 1. So you could see here 1, 0 is 0, 1, 0 is 0. Here it is 1, and here it is 1. So it's quite simple. Let's see the OR operation. Again, I'm taking the same example. This is 0F H, and this is your ACH, and I'm loading this to the accumulator, and then I'm using this OR operation in place of AND. I will use ORL here. Okay, so what will I get as an answer? So if I draw the truth table for OR, it will be X, Y, and I'm writing OR here. So for 0, 0, output is 0. For 0, 1, output is 1. For 1, 0, output is again 1. And for 1, 1, output is 1. So you could easily see here. Next, take XOR, and in XOR. Let's see the truth table of XOR. So X, Y, and XOR. So 0 0 0 1 1 0 1 sorry 1 1. So for 0 0 uh, it is 0, for 0 1 it is 1, it's 1, and here it is 0. So you can verify it here. So let's move again. Let's take look at the complementary function also. I'm again taking the the ACH value. I'm trying to complement it. Okay, so I can do it by moving this value into a move a hash 0 is 0 ACH, and then I'm complementing the content of a, so CPLA. So after the execution of this, we will get this bitwise complement. Okay, let's move. So what is the basic use of using the logical instruction in 8051? So if I am using AND instruction, then will basically force individual bits to low without affecting the other bits. You can see this example. Say I am trying to AND the content of PSW with this. So basically two bits, these two bits will be forced to 0. Okay, this is your D0, D1, D2, D3, and D4. So D3 and D4 bits will be forced to 0 of the PSW. Similarly, or or in OR, what happens, the individual bits are forced high. Okay, so when I am keeping it equal to 1, then uh, again the D3 and D4 bits of PSW will become 1. Whatever be the content in PSW, D3 and D4 bit is going to become 1, while rest of the bits will be unaffected if I am using 0 here. So what is the use of then XOR? So it complements the individual bits. Okay, so if I am using 1 here, so the D6 bit of actually I have used here the port P1. So D6 bit of the port P1 will become 0. Okay, the rest of will be unaffected. Okay, so these were some of the logical. Now let's move to some other logical instructions like your clear, RL, and we will see them. Okay, let's see the clear instruction. Clear is a byte as well as a bit instruction. Okay, and as you could see here, it can operate on any byte, the register mode also, and the indirect mode also. So all types of mode are possible in case of clear instruction. Basically it moves 00H to, say for example, if I am trying to clear a, then a will be the 00 will be uh, copied with this value 00 and so on. Let's move on. Now let's see the rotate instruction. So rotate is rotate left and rotate right. Okay, and it operates only on the accumulator, I told you earlier. So let us see here. So I am first trying to move a number F0 into a, and F0 is this number. Okay, so let me write it here. So this is 1 1 1 1, and this is 0 0 0, and again 0. Okay, so what it means, rotate rotate uh, rotate left. I think there is some error here. It will be rotate left, RLA. Okay, so uh, what happens, each of the bit will rotate to the left side, and this 0 will move here, this 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 will move here, and this will move here, and the D7 bit will come to the LSB, the lowest significant bit. So the result will be this. Okay, Similarly, rotate right, it works in opposite fashion. Again, I am writing 1 1 1 1 and 0 0 0 0 here. Rotate right means now I will be rotating this on this side from left to right. Okay, so each of the bits will be moved to the right, and the rightmost bit will move to the move to uh, the most significant bit, so it will come here 0. So you could see here. Fine, let's move and see the rotate through carry. So RRC and RLC, there are two instructions: rotate right through carry and rotate left through carry. So the carry bit of the program status word is incorporated in this instruction. Say I am writing a value of A9 in accumulator A. So A9 is this 1 0 1 0 1 0 0 1. Okay, and I'm adding this number to A. Okay, 14H. So if I'm adding these two numbers, what I will get? 9 plus 4 is D, and A plus 1 is B. So BD. So A will be having a value of BD, as I have written here, BD. And these addition do not result in setting of carry flag. So carry flag is 0. C is 0. Okay. Now, if I am writing this rotate right carry instruction, what will happen? So all the bits are going to rotate to the right. Okay, this will move here, this will move here, this will move here, 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 and this here, and this here, and this will move to the carry, and the content of carry will be moved back to the most significant bit. So as you could see here. Okay. Similarly, in case of rotate left with carry, the thing opposite happens. So if I am using different sets of instruction are here. So 3C has been written in A. 3C means 0 0 1 1. Okay, then 1 1 and 0 0. So then I am writing set B C. I am basically setting the carry flag. So C becomes 1. The carry flag, it becomes 1. So this is 1. Now I am rotating each of the bit to the left. So this carry will move here, and this 0 will move here, and this here, and this here, and this here, and it will move so on. And the most significant bit will take the position of the carry. So this will be the result. Okay. And another important thing we can obtain with the help of the rotate right and rotate left instruction is that basically uh, left shift is the same as multiplying the number by 2, while right shift is same as dividing it by 2. We'll see it with the help of an example. Say I am moving number 3 to A. So this is your number 3 and it has been moved to A. I'm clearing C. Okay, then I am rotating the number to the left, the content of A to the left. Okay, uh, and this I am using RLC, rotate left with carry. This is with carry. Okay, so what is happening? Our carry was having 0, so 0 will come here. Okay, and 1 was here, so 1 moves to the higher place. Again, this 1 moves to the higher place, and so on. And the MSP, which was 0, will move to again carry, which is 0. So this, the resulting number is 6. So you can see 3 multiplied by 2 is 6. So similarly, if I'm taking RLC, rotate left with carry, I'm again rotating left with carry. Okay, so the position of 1 shifts to the left, and now the resulting number is 12. So again, it has been multiplied by 2. If I am doing operation with RRC, rotate right with carry, then what happens? This 2 bits move back, and the resulting number is 6, which is basically 12 divided by 2. So we have achieved division by 2 here. So RLC will result in multiplication by 2, and RRC will result in division by 2. And please remember that these two instructions operate only on the accumulator. So uh, another instruction is swap.